Hi, this is Ken Rosever. I didn't want to be up this late tonight, but I want you guys to be prepared. And I just want to make sure that I do a little review video on solving an equation for a specified variable. So I'm going to give us 5 problems that I went over in my other class as examples. These aren't the exact same problems that I went over in my other class, but they're of the same type. So let me go through each of these. I'm going to write them out, and then I want to encourage you to try them on your own first. Actually, instead of writing them out, let me hit this, go down here, and this is my notes from the other class. There they are. So try each of the following. I'll make it in big view. Try each of the following. They are in order of increasing difficulty. Number 1, I want you to solve for y, and it's a linear equation. You should know that from intermediate algebra. Number 2, solve for h. A equals 1/2 h times b1 plus b2. That's the area of a trapezoid. I want you to solve for h. Also a problem I would expect you'd be able to do coming out of intermediate algebra. Number 3, solve for r. It's the formula for a volume for a cone. I think we did this one in class. In fact, I think we did this one as well, so those should just be review. Problem 4 says solve for L, and we have S equals 2LW plus 2WH plus 2LH. And finally, solve for X, given y equals 2x minus 3 over x. The last two are challenging because you have to isolate the terms with the variable you're interested in on one side, then you have to factor and divide. So take a little time out now, copy those down, and try each one out. And when you come back, I'll go over to the other page and I'll walk you through each one of these. So hopefully you've tried the problems before you've gone on. So here's the first one. Number 1. It says solve for y. So I'll just write y. That's what we're interested in. And the equation we're given is 2x minus 3y equals 7. So y is what we're trying to isolate. So the 2x needs to go before we can attack that coefficient. So I'm going to minus 2x from both sides. So that gives me negative 2x plus 7 equals negative 3y. Then dividing everything by negative 3, we get negative 2x over negative 3 plus 7 over negative 3. Cleaning it up where we can, we get this. If the problem wanted in function notation, because this is a y, I could actually go f of x is 2/3 x minus 7/3. But, you know, our goal here was to get y by itself, and we did that. The second problem I had on the other page was to solve this trapezoid formula, which is the area is 1/2 the height times the top base plus the bottom base. This is the area of a trapezoid. I want to solve it for h. So, erase that. Well, I notice h is getting multiplied by half and is getting multiplied by the quantity b1 plus b2. We do not want to distribute here because it separates h into two places, and we don't want to separate h and spread h out. We want to isolate h and get it in one spot and everything else on the other side. So I'm not going to distribute h. I'm going to keep it together. It's kind of difficult to see my pen sometimes. There it is. So first thing I'm going to do is I'm going to double everything, giving me 2a. 2 times 1/2 is 1, so 2a equals h times b1 plus b2. This quantity is multiplying h, I can divide both sides by b1 plus b2, and I get that h is 2a divided by the quantity b1 plus b2. So that's our first two. I'm going to scroll down. I'll keep this all on one page, I think. Let me add some room. Number 3 is relatively straightforward. We want to solve for r, and we want to do that in the equation v equals 1/3 pi r squared h. So what is happening to r? It's being squared and multiplied by a bunch of stuff. So I'm going to divide out that stuff. To divide out a third, or to get rid of a third, I multiply by 3. Multiplying both sides by 3 gets rid of that fraction and leaves me with pi and h times r squared. So my next step will be to divide out the pi and the h, and I can do that at the same time, leaving me with r squared equals 3v over pi h. So r equals the square root of 3v over pi h. Now technically when you take a square root you should write plus or minus because there's two solutions, but since the actual context of this formula is that r is the radius, we know the radius is never negative. Looking at number 4, we want to solve the equation which represents the surface area of a prism. So it's S equals 2LW plus 2, what did I say, WH plus 2LH. And we want to solve that for, no kitty cat, we want to solve that for L. So I'll just write for L over here. So I need to first focus in on every term that has an L in it. This one does, and this one does. So everything that does not have an L needs to go to the other side. No kitty cat. So S, I'm going to bring this over, minus 2WH equals 2LW plus, now he's licking my arm, 2LH. Alright. Now that I have all the L's on one side, I am going to factor out the L. Everybody, you want to meet my cat? This is one of my cats. He's a good boy. Alright. So I factored out the L. I can't see. And whoa, whoa, whoa. Come on, man. And that is still equal to this quantity. So my last step here is to divide this quantity over here on both sides. So I get S minus 2WH over 2W plus 2H equals L. And that is my answer. I can't cancel out the 2's there because you can only cancel common factors, and 2 is not a factor of every term on the top. It's a factor of both terms on the bottom, but so what? You can only cancel out common factors, and it's not a common factor between the numerator and the denominator. Which brings us now to our last problem. In our last problem here, we also have the variable that we're interested in isolating located in more than one place in the equation. So let's see, we have, this is number 5, and we're looking to solve for x, and the equation we're given is y equals 2x minus 3 over x. So first thing I'm going to do is I'm going to multiply everything by x to get this x out of the denominator. Having done that, no x on the bottom, but now I have an x over here. I want to get all the x's on one side. I can do that one of two ways. I can bring the 2x over, so the xy is still there, but I'm going to minus 2x And that leaves me with a negative 3 on the other side. Okay. Having done that, I just need to factor out the x. And that gives me x equals negative 3. Dang it. You're making this take much longer than it should. Stop. Okay. Negative 3 over y minus 2. Alright, hold on a second. You, mister, are now going on the floor. Alternatively, if you didn't bring the xy over, let me go back here. Alright, you could have, instead of bringing the 2x over, you could have brought the xy over and the 3 the opposite way, and then you would have gotten this. And you would have gotten a similar result. After you factor this, you'd have x times 2 minus y equals 3. And when you divide, you would have that x equals 3 divided by 2 minus y. Now these look a little different, these two answers, but in fact they are the same. Because negative 3, if you move that negative to the bottom, you have 3 over negative the quantity y minus 2, and when you negate that quantity, you get 3 over negative y plus 2, which is the same as x equals 3 over 2 minus y. So there's our answer there. You can expect to have one problem on your test which you will have to use factoring to solve for the variable. Okay. Welcome to College Algebra. I hope this was helpful, and I wish you luck in your studying for this first test. Adios.